Hello, and just a quick explanation of this introductory activity for the gallery walk. So the following diagram is of a gallery walk. People will be starting in room A. There are 1,024 of them, and after a 5-minute period, they have a choice of either moving to the next room or staying in the room they're currently in. They can't go backwards. So they're either going to move on. Then it said, assume that an equal amount will choose to move on as staying. And so the idea is to get an introduction to these transitions and how it's going to work out. We're trying to figure out how many people will be in each room after 1 hour. So, all right. So in the beginning, there would be 1024, right? And of course, nobody's in any of the other rooms, and nobody is outside yet. So after 5 minutes, it says half of them, so 512, will stay, and 512 would move into room B. Nobody would be in C. So you can show that to your students to get them started, and then have them work it out from there. So in problem 2, the beginning would be the same. 1024, nobody. 512, 512, nobody. And then here's where you gotta kind of pay attention. After 10 minutes, these 512, half of them, so 256 are going to stay, and 256 are going to go into room B, but also 256 that are already there are going to stay. So together, that's still 512, and then 256, and then nobody else. And then if you want to check yourself, you can always add up, and it should total. You shouldn't lose people or gain people. It should be 1024 each time. So 15 minutes. So half of them, so 256 divided by 2, 128 will still be here, and 128 are going to move to room B with the half, the 256, that'll stay. So 256 plus 128, 384 would be in room B. Half of them, the 256, would move up to room C and join the half, which is the 128. So 256 plus 128, so 384. And then half the 256 should move up. And again, if you add those up, it should total. So that's the idea. And then I have the students do that on their own. Check with me to make sure they're getting the idea. And then the rest of it is, and I'm not going to go through that, but it's everything over again to try to figure out how many people are outside or in each room after 1 hour. And then, I guess I should have said this at the beginning. If you're a teacher watching, I usually give this to them as an activity from the end of the day before. If they have a quiz or anything, have them start this after the quiz, or to get them ready for the Markov chains. All right, so in this one, you have 8,748. Now at each 5-minute interval, an equal amount of people will move on to the next room, stay in the room, or go back to the last room. So, but when they exit the building, they will not return. So once they go outside, they won't come back in. But now, of course, room A, half of them would go to room B, 8748. Oh, 8748 divided by 2. So 4374 and 4374 for the next 5 minutes. But then the people at A can stay in A, move to B. The people in B can actually move back to A, stay in B, or move to C. So half of these guys, 4374 divided by 2. So 2187 are going to stay in this room, but 4374 divided by 3, 1458 of them are going to move back into room A. So 2187, 1458. So there would be 3, 6, 4, 5. And then a third of them plus the half that move would be 3, 6, 4, 5. Plus a third, which was the 1458, would move up. As they end up getting decimals and stuff like that, you end up having to round to people and stuff like that, but that's the idea, to look at transitions before they actually learn how to do a Markov chain, so they see what Markov chains are achieving for them. Alright, so that's the introduction, and then you can share that with your students if you like that introductory activity. Thanks.